Hello, my name is Carter McCullough, and I am a researcher at Valparaiso University. I'm a senior majoring in bioelectrical engineering, and today I'll be talking about my poster titled Applications of Haptic Technology in Engineering Education. Before I begin, I would like to thank Professor Reba Johnson for giving me this opportunity to do research over the summer and for being extremely supportive in doing said research. To begin, let's start off with a brief introduction of haptic technology. The word haptics is derived from the Greek word haptikos, meaning related to the sense of touch. We would like to use this haptic technology to provide a more top-down or big picture learning perspective compared to traditional teaching methods like lectures and reading. A formal definition would be that it is the study of integrating neuroscience, psychology, robotics, and virtual reality to accomplish two goals. One, understanding how humans perceive and use touch sensations, and two, creating touch sensations using mechatronic systems. Previously, our project goals have been focused on how haptic technology can be used to improve intuition and retention of engineering concepts. While we did see some promising results, we saw this as an opportunity to improve on certain areas of the study. Therefore, our research has shifted towards optimizing the haptic learning system by improving the quality of the haptic feedback and modifying the learning environment. In our previous study, to teach the concept of static friction, a fundamental statics engineering concept, we used the haptic environment shown here. As you can see, it is pretty bare bone and there is not a lot of guidance on what the user should be learning. That is why we decided to redesign this lab to better integrate the concepts of friction and slipping/tipping and to make it look more professional. I believe the best way to explain the improvements would be to show you a demonstration of how a student would navigate the environment. In this video, I'll be showing you how we can use the Happily robot to teach a student the concept of friction and slipping and tipping. So in this environment, I'm able to interact with this block here, and I'm actually able to feel all sides of the block with this Happily robot, and I'm not able to move my cursor through this block. So in order to teach the concept of static friction, you must understand that in order for this block to move, my pushing force must overcome the static friction that is within the block and with the ground. So for demonstration, if I were to just touch this block, my pushing force is extremely low and will not, and since it's less than the static force, it will not move. But once I increase this value over 0.072, the block starts to move. Again, if I just touch it, then it will not move. But once I go over 0.072, the block starts to move. This number can be changed, however, by changing the coefficient of static friction. So if I were to change this to 1, it takes a little bit for the block to update. You can see that the static force is now 0.18 instead. So if I were to push this, it now requires 0.18 in order for it to move. Another feature that we have in this simulation is the ability to see the tipping moment required for the box to tip instead of slide. So sliding looks like this, and then you also have tipping as well. And in order for that to happen, the pushing moment must overcome 0.27. So if I hold it here, once that comes over 0.27, I'm able to tip it. However, if I come from down here, the pushing moment is not greater than 0.27, therefore the block will slide instead. But once it becomes greater than 0.27, the box will begin to tip. And as always, if you were to change the coefficient of static friction down to 0, the box will begin to behave like a hockey puck. So now that we redesigned our friction lab for our experiment, we would like to implement this model into a classroom environment to better understand how students interact with the environment and to see its effectiveness at teaching the engineering concept. We would also like to build a new design for the Hapley robot, as seen on the left. This design will provide more support for the motors, which will in turn stabilize the end effector's movements for a more lifelike experience. Finally, as always, we are seeking a variety of engineering concepts where haptic feedback would be beneficial to teach with. In my closing remarks, I hope you enjoyed this video and learned something from it, and I thank you very much for watching.